Okay, so I'm going to go over lesson 8, determining the slope of a line from a table of values, which is the lesson from October 23rd, which is Friday's lesson. Okay, oh, there it is. Okay, so we start out by graphing the linear equation below using a table of values, which is something that we did about a week or two ago. So when you want to graph by using a table, you have to make up a table with a bunch of different x values, take those x's, plug them into the equation, and get the y. So we like to use x coordinates that are going to be on our graph that we can see here, so in between -9 and 9. So let's just pick from -3 to +3, nice and centered. So let's make our table with our x values going from -3 to 3. Okay, so now I'm going to take my x values, plug them into my equation for x, and see what the y is. So for the first one, my x value is -3, so I'm going to plug that in. 2 times -3 is -6. -6 plus 3 is going to give me -3. So that means my y coordinate is -3. Okay, then we're going to do it again. So y equals 2 times, plug in -2 for x, and see what you get for the y. This time we're going to get -1. Okay, now when x is -1, so let's plug in for -1 for x. 2 times -1 is -2. And again, you could just put this whole part in your calculator. So we're going to get 1. Plugging in 0 for x, so that would be 2 times 0 plus 3, which is going to be 3. Let's see, the next one, 2x plus 3, 2 times 1 plus 3 is going to be 5. Oh, sorry. 2 times 2 plus 3 is going to be 4 plus 3, which is 7. And then the last one would be 2 times 3 plus 3, which will give you 9. Okay, just plugging in the x values into the equation to get the y. Now we can plot the points. We have a bunch of points, so that'll make a line. -3, -3, -2, -1, -1, 1, 0, 1, 0, 3, 1, 5, 2, 7, and 3, 9. Okay, they look collinear to me. Nice straight line. They all line up perfectly, which is a good sign. And label. Okay, so that was a recap. That was review. Now let's move on to our essential question. How can we determine the slope of a line from its table of values only? All right, so we learned already how to find the slope by looking at a graph, right? We did rise over run. How would you figure out the slope if you didn't have any of this and you just had that table over here? So, just like how we learned that to find slope you do rise over run, when you're doing rise, that's the change in the y's. It's the change in the up and down. So change in y, that's the rise. Over the run, when you're running, you're going left and right. So you're looking at your graph how far you're changing in the x's. That goes in the denominator. Change in y over change in x. So the change in your up and down, the change going side to side. So if we look here at our table, let's get a different color. The change in y, right, so we'd said that would be going up and down here, but without looking at the graph, we could go here and see how much are our y's changing as we go from -3 to -1. So to get from -3 to -1, you're adding 2. To get from -1 to 1, you're adding 2. To get from 1 to 3, you're adding 2. To get from 3 to 5, these are the y coordinates, the change in y. You're adding 2 every time, so our change in y is 2. Let's look at the change in x. We'll start down here because it's easier. To get from 1 to 2, you're adding 1. To get from 2 to 3, you're adding 1. To get from 0 to 1, you're adding 1. Negatives are a little bit harder, but let's think about it. To get from -3 to -2, we're adding 1. And you could plug these into your calculator to check. You could say, is negative 3 plus 1 negative 2? And yeah, it is. Okay, camera's falling there. All right, so our change in the x's would be 1. 2 divided by 1 is 2, so there's our slope. And remember from the other lesson, rise over run, it is indeed up 2 over 1. So 2 over 1, which is 2. But it's important because today we're going to be just looking at tables and not the graphs. Okay, so here's our checklist. Determine the change in the x, determine the change in the y, and write it as change in y over change in x. A lot of people want to put the x on top. Please remember, rise over run. The rise up and down, side to side, is on the bottom. Change in y over change in x. All right, let's try some tables. So now we have a bunch of tables. We don't have graphs, so we have to use the change in y over change in x formula. Okay, so I'm just going to write that off to the side here. We're doing change in y over change in x. That little triangle just symbolizes a change. Okay, so to figure out the change in y and the change in x, so let's look at the top first. So we're going to see how much we're changing by from one x coordinate to the other. So to get from 1 to 2, we're adding 1. 2 to 3, we have to add 1. From 3 to 4, we're adding 1. So our change in x is 1. Our change in y, to get from 0 to 4, we add 4. To get from 4 to 8, we add 4. And to get from 8 to 12, we add 4. So our change in y, which goes in the numerator, is 4. 4 over 1 simplifies to 4. Okay, let's look at B. Change in y over change in x. The change in x, 2 to 6, we have to add 4. To get from 6 to 10, we have to add 4. To get from 10 to 14, we have to add 4. To get from 1 to 7, we have to add 6. To get from 7 to 13, we have to add 6. To get from 13 to 19, we're adding 6. Our change in y is 6. Our change in x is 4. This one we can simplify by dividing both the numerator and denominator by 2. And then we will get 3 over 2 for our slope. Okay. And again, we're finding slope. Okay, this table is written a little bit differently. It's vertical instead of horizontal, but that's fine. Change in x is going to be over here. Change in y on this side. Okay, so the change in y over the change in x. So I'm going to look at my change in y first because that's going to go in the numerator. To get from 12 to 9, we're going down, so we're minusing 3. 9 to 6, you're minusing 3. Minus 3 to check. 6 minus 3 is 3. Yeah, okay. So my change in y is negative 3. Change in x goes in the denominator, remember? To get from 1 to 2, we're adding 1. 2 to 3, adding 1. 3 to 4, adding 1, so positive 1. Negative 3 over 1 is negative 3. So this is we're finding slope. Okay, this table, change in y over change in x. The change in y, to get from 5 to 4, we're minusing 1. 4 to 3, minus 1. 3 to 2, we have to minus 1. Double check. 5 minus 1 is 4. Yeah, 4 minus 1 is 3. Okay. Change in x. How do you get from negative 6 to negative 4? Well, you have to add 2. Negative 6 plus 2 is negative 4. Negative 4 to negative 2. Negative 4 plus 2 is going to give you negative 2. And negative 2 to 0. Negative 2 plus 2 is going to equal 0. Okay, and if you're not sure with the negatives, you could go backwards and subtract. So you could have done 0 minus the negative 2. Negative 2 minus the negative 4 to find the missing piece. The best way to check it, though, is to just look back over and see, is negative 6 plus 2 negative 4? And you can put that in your calculator and make sure it is. Okay, so the change in y is negative 1. The change in x is positive 2. So our slope is negative 1/2. Okay, E. To get from negative 6 to negative 5, we have to add 1. Add 1, add 1. Negative 4 plus 1 is negative 3. And again, if you're not sure, you can go backwards and subtract. -3 minus a -4. You're going to get +1. All right. So I'll just write that off to the side in case you were stuck. So if you can't figure out that with the negatives, like how you get from -4 to -3, you could go backwards and say -3 minus -4. That's going to give you that +1. Okay, but again, just check it in your calculator. -6 plus 1 is -5. Yeah, okay. X's. Sometimes it's easier to start off with the positives. Like how do you get from 2 to 7? That's probably the easiest one. 2 to 7, you have to add 5. So then you could just check that for all of them. -3 plus 5 is 2. 2 plus 5 is 7. 7 plus 5 is 12. Change in y over change in x. My change in y is 1. My change in x is 5. My slope is 1 over 5, 1/5. Okay, another horizontal table. To get from 0 to 3, we add 3. 3 to 6, we have to add 3. And then 6 plus 3 is 9. And again, check it. If you're not sure, you can go backwards. 9 minus 6 is 3. 6 minus 3 is 3. But I think the easiest way is to go forward and say this plus what is going to give me 3. Okay, how do I get from 9 to 7? We're going down, so we're subtracting. 9 minus 2 is going to give me 7. 7 minus 2 is going to give me 5. And 5 minus 2 is going to give me 3. Change in y over change in x. My change in the y's is -2. My change in the x is 3, so -2/3. Okay, plot the points from the table of values below on the coordinate plane provided. Okay, so we're just plotting some points. So -2, -6, 0, -2, 1, 0, and 4, 6. So these are collinear. They are going to make a line, but you're probably noticing something a little bit different about these. They're not evenly spread out. These two are super far away. These two are super close. And then we got that one down there. So our question, do the points from the table form a straight line? So yeah, that's a straight line. But what is the slope of this line and how do you know? So we've been teaching you guys from a graph, you can do rise over run, which we can do here, but you're going to notice it's going to be different in different spots. So let's see what happens. Okay, so I see down here, let's do this one first. The rise, we're making our slope triangle to go from left to right. You're going to have to go up 4 and then over 2. So my slope is 4 over 2, which is 2. Okay. What if I did the slope? Let's get a different color. What if I did the slope from these two little points? Well, then it would be up 2, run 1. But that's okay. My slope is still 2. And what if I did the two far away points? To get from here to here, we'd have to rise 1, 2, 3, 4, 5, 6. And then run 3. 6 divided by 3 is 2. So the slope is 2, no matter which points you do it between, the rise over run. So if you look at our key idea, we can determine the slope of a line by knowing any 2 points that fall on the line. No matter which 2 points we use to find slope, the slope will always be the same because a linear function has a constant rate of change, a constant slope, no matter which 2 points you go between. And I'm actually going to show you the farthest ones. What if you want to go from this point all the way to this point? I don't recommend it. You should pick 2 that are closer together. But it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, I went 1 too far. 12. And then you would run 1, 2, 3, 4, 5, 6. So that would be rise of 12, run of 6. 12 divided by 6 is still 2. Giant slope triangle. Okay, so a linear function has a constant rate of change, a constant slope, no matter which 2 points you use. Very important, because let's look at these tables now. Each table of values represents a line. Determine the slope of each line. Okay, so we know, just like the other ones, we have to do change in y over change in x. So let's see what happens as we look at our change in x. To get from 1 to 3, you're going to have to add 2. To get from 3 to 4, you have to add 1. To get from 4 to 7, you have to add 3. So this is inconsistent so far. But let's see what happens when we do the change in y. To get from 11 to 6, you're going to minus 6. 11 to 5, you're going to minus 6. 5, let's see, 5 minus 3 is 2. And then 2 minus 9, oops, I don't know why it's there. 2 minus 9 is going to give you that negative 7. So the other ones we had all had the same change in y over the same change in x. Let's see what happens here. If we wanted to use these points, we would look at the change in y is negative 6. The change in x is 2, which is going to give us a slope of negative 3. Okay, what if I wanted to look at these points? The change in y is negative 3. The change in x is 1. Negative 3 divided by 1 is still negative 3. Oh boy, I'm going to need another color. Just use black. These two, the change in y was negative 9. The change in x, 3. Negative 9 divided by 3 is still negative 3. So what we're trying to show you here is that even though you're going to be using different numbers sometimes for the change in y over the change in x, it doesn't matter which 2 points you pick. If it's a line, it's going to have a constant slope. The slope will be the same no matter which 2 you pick. You just might have to do some simplifying. Okay, so let's look at B. To get from negative 7 to negative 3, you have to add 4. And again, if you're not sure, go backwards. Negative 3 minus a negative 7 is positive 4. To get from negative 3 to negative 1, so let's see, negative 3 plus what is going to give us negative 1? Negative 3 plus 2 is going to give us negative 1. Negative 1 plus 4 is going to give us 3. If you're not sure, go backwards. What's 3 minus a negative 1? You'll get 4. Negative 1 plus 4 is 3. Oh boy, big ones. Okay, negative 44 plus what is going to give us negative 16? If you're not sure, do negative 16 minus a negative 44. You're going to get that you have to add 28. Okay, to get from negative 16 to negative 2, you're adding 14. Negative 16 plus 14 is negative 2. Negative 2 to 26, you're adding 28. If you're not sure, go backwards. 26 minus a negative 2 is 28. All right, change in y over change in x. 28 is the change in y. 4 is the change in x. 28 divided by 4 gives us 7. So 7 is our slope. We can stop there because you just have to pick any 2 points. So we picked these 2. But since it's a lesson, I'm going to go ahead and show you all of them. What if you had picked these 2? Then you would be doing 14 over 2, change in y, change in x, which is still 7. Okay, and what if you had picked these 2? Change in y is 28. Oh, that one's the same as before. Over change in x, which is 4, and you get 7 again, because that's the same as the 28, and 4 is the same as the other one. Okay, so just remember that a linear function has a constant rate of change. So even if these numbers, when you're finding like the pattern, are different, it could still very well be linear, especially if it's telling you it represents a line. You just have to pick any 2 to find your slope. All right, so I hope that helps. Again, that was lesson 8 from Friday. All right, bye.